So very good evening. So all of you done your assignment?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir. So now you are familiar with R, how to write codes in R. Now it is okay to you. So anyone have any problem regarding the assignment?
Sir, actually, I could not do question assignment number 5 because an error was coming up continuously, and I did not understand what was the question in assignment 4.
So my suggestion is, since there is a WhatsApp group, those
Yes,
who
sir.
solve the those who are able to solve question number 5, please share the script after the end of class.
Yes, sir.
Clear? So if they share, then you watch what are the mistake that you do when you write the code, and automatically you rectify your code. And another thing is there is a little bit of confusion regarding WhatsApp group members and class members. Uh, Nilendo also writing sometimes that those who are not registered, please remove yourself from the group. But there is a problem. Some student is there or individual is there uh, who are not continuing the class but in the group. And don't worry, if they try to learn by seeing the PPT or doing the assignment, so don't worry, they can learn. So don't hesitate, because this is the era of internet. Google is there, everything is available. Nothing is private now. So don't hesitate to give note to other friends or students. So that's why I am following the WhatsApp group, not the mail. Be clear. Uh, Someone writing me that you give me in mail rather than in WhatsApp group. So don't worry. If they can do it by using the PPTs and the assignments. So I think it is clear to all of you. Or any other doubts regarding last 2 days class after watching the PPTs and doing the assignment?
No, sir.
Today, basically, we try to discuss the statistical inference theory. So, basically, today's session, 90% of the time is for the statistical theory, and only 10% I allot for R code. The basic thing is, if you don't know the statistical theory or the basic theory, you cannot write the code for statistical analysis. So, you have to know the theory, when to use which, and then how to use. So first and foremost thing is when to use which. So you have, basically, this is the world of lots of data, and some term is now you known with big data analysis or artificial intelligence, deep learning. I think you know all these terms. So basically all are based on some statistical and mathematical theoretical foundation. So as long as it is not clear to all of you, only knowing the softwares or codes, it's not beneficial for you. Uh, Basically, I am in this particular field from 2006. Uh, in numerous number of workshops, I am a research person in SPSS, in Stata, in R, in Jamovi. But believe me, the fact is, as long as you don't know the statistical theory, the foundation of the statistical theory, it is not possible only learning software, you can write a paper or you can do your research. The fundamental thing is you have to know the statistical theory. And what are the theory? Basically, it's 3 points. After getting the data, what the statistical analysis suitable for your data? This is a basic question. So, say for example, there is a census data. You know there is a NSSO data. Data on Human Development Index. If you go to the FAO site, there is lots of data available for agricultural statistics. Infrastructural development statistics also available. One data source is data.gov.in. This is for the Indian government data site. Lots of data is available. But what to do with the data? Some may perform some primary survey. So after collecting the primary survey, what is the suitable analysis? And in most of the cases, believe me, in most of the cases, the researcher collecting data, make some questionnaires, but after collecting data, they are confused. Which statistical analysis they can use? And basically, for in our domain, basically in economics, we are always trying to fit a regression model. It is a Welles regression or a panel data regression or time series regression. This is our basic orientation. Collect data and we try to find out some causal relationship between two variables or between one or more variables. But that also depends on some statistical theory. And assuming that you all know the basic descriptive statistics, that is what is mean, what is median, what is the meaning of skewness, kurtosis, simple correlation, and the basic concept of regression, you all know. In your syllabus, you all know that. Assuming that you all know this, today I basically discuss the statistical inference theory. Before doing that, basically when we do any analysis with the help of data, what we do actually, we try to estimate the population parameters on the basis of the sample statistics. So that means first we have to clear what is the concept of data. In previous class, I tried to explain the nature of data and basically concept of data and concept of variables. If you remember, I was mentioned that there are basically 4 types of variable that is measured in terms of different scale. One is nominal scale variable measured in nominal scale, one measured in ordinal scale, and one measured in ratio scale. Another is interval scale. So the example of interval scale is simply the thermometer. It's the interval scale. So, and what is the difference between ratio scale and interval scale? In interval scale, 0 may or may not be included, but in ratio scale, 0 must be included. The basic difference between ratio scale and interval scale. But when we measuring the variables in terms of nominal or ordinal scale, that data is basically a categorical data or discrete data. But when we measure the variable in terms of ratio scale or interval scale, that data is a scale data. It may be discrete or it may be continuous. So when the variable measured in scale, that is in ratio scale or in interval scale, that data may appear in discrete form or continuous form. But if the data measured in nominal scale or ordinal scale, then the data must be a categorical data and it must be a discrete by nature. So this is the basic concept of data and variable and simple concept of scaling. Next is concept of parameters and statistics. So all of you know what is parameter and what is statistics. Can you explain anyone what is parameter and what is statistic?
Yes, sir. Parameters are based on the population and statistics are based on the sample.
Population is based on parameter and statistics is based on
Samples.
sample. Any other modification of this definition? Any modification? Or all of you think it is the true definition?
Like, sir, it can be placed in this way as well. Like, any statistical measure which gives an idea about the population, that is my parameter. Like population mean and population ST. And conversely for statistic, any measure which gives me an idea of what the sample is about.
So what is population? Suppose this is the population. This is the population. What is the meaning of population? When we consider the total, this is the totality. So suppose we are trying to working on the 12 standard students who just passed the 12 standard on their average performance in mathematics. So what is the population? Population means when you consider all the candidates who passed just the plus 12 with mathematics. So this is the population. It is from Bengal board, from Odisha board, from ICSC, from CBSC, whatever be the board. If we consider the Indian student, then the population consists all the students, right? So the population characteristics, rightly said, on the basis of the population, the actual definition is what is parameter? The characteristics of population is termed as parameters. So what are the characteristics? First is mean. So when you're talking about mean, so the population mean is denoted as mu. Population variance, this is denoted as sigma square. So when you're doing our research, someone may consider the entire population, all the data from all plus 12 students with mathematics as a subject in plus 12 is plus 2. Or one can collect some individuals from this population. So one can collect from here information of some individual, that is termed as sample. That is termed as sample. When we collect information from the population, and the sample characteristics is known as statistic. So we denote this mean as x bar, variance as s square. Similarly for skewness, kurtosis, notation is there. So the problem is, suppose this is the sample 1, S1. Another one researcher may collect another sample. This is S2, right? This is S2. And for that case, suppose this is X1 bar, this is S1 bar. And for S2, it is X2 bar, and variance is S1 bars. So in India, different researchers can work on the same topic. Different researcher collecting different sample. So in someone's case, the mean is X1 bar. In someone's case, the mean is X2 bar. And the population mean is mu. So what is the problem arises? The problem arises which sample is best fit to the population, or which researcher's result is acceptable. Is the researcher who collecting the sample size S1, his result is correct, accepted, or the second researcher who is working with sample S2, that result is accepted. So this is the basic problem in statistics, and that generates the concept of estimation or estimator. What is the meaning of estimator or estimation. In statistics, we try to estimate this population parameter with the help of these sample statistics. So basically, what is the goal of the statistics? The goal is estimate this with the help of this one or with the help of this one. So this is the basic concept of estimation. And a good estimator have different properties. Unbiasedness is there, minimum variance is there, consistency, sufficiency, lots of properties are there. This is written in books of statistics. If you are not from statistics past student, only from economics honors, you can go to the book of Gungupta Dasgupta. Everything is detailed analysis is there regarding the properties of estimator, etc., etc. But our orientation in today's class is not going to the detailed statistical analysis, only the conceptual analysis. So first, what is our objective when we do our research? So the objective or the goal is to estimate this population parameter with the help of these sample statistics. So this is the basic concept of estimation. And another thing is, then the concept comes is hypothesis, and then the questions come testing. So I will discuss hypothesis testing later on. First, you consider this example. This is a very funny example. We all do when we take selfie. You all take your selfie when you meet with the friends, and someone is move their head in right direction, someone move their head in left direction. It may happen. If you go to your own picture in own gallery, you see your selfie, no one's head is straight. Someone head is in left direction, someone head is in right direction. It has happened. So the question is, a neonatal right side preference makes a surprising selfie image later in life. So there is a biological problem in general in neonatal sense. In when a baby borns, in initial stage there is a right side tendency, and if the right side is this right side tendency have any impact on the adolescent sense or in future age when they take some selfie. So if the individuals when they take selfie, their head is moved towards right direction or not, and here let P denote the proportion of persons that turn their head to the right when taking selfie. So what is our objective? Our objective is to prove if the proportion is exactly 0.5, then it is okay. 50% is moving towards right, 50% is moving towards left. If the proportion is more than 0.5, that implies neonatal right side preference have some impact. More people is towards in right direction. So how we solve this problem? So to solve this kind of problem, what is the requirement? Requirement is we have to make a statistical, we have to design a statistical experiment. So when we try to make a statistical experiment, that means what we can do? We collect some pictures from either Instagram or Google Photos or anywhere from net or directly from some friends, and after collecting the pictures, we can categorize the pictures with right-headed and left-headed, and say if we call 1 as right and 0 as left, so automatically we can calculate the frequency of the individuals while taking selfie. They have right-headed picture and 0 for left-headed picture. And if we consider this example, hypothetical example, suppose n is 124, that is we collect 124 pictures, 80 of them to the right direction. So what is the proportion? It is 64.5. So it is more than 0.5 or 50%. So the conclusion may be neonatal right side preference have some impact on selfie taking. It may be concluded with the help of this particular case. If we collect 124 samples and 80 out of this is right direction. So what we actually do here, sorry. So R is 1 when it is right side and 0 when it otherwise not left. We are considering it otherwise. So what is P? P is nothing but summation R by N. This is the proportion. Summation R by N is the proportion. And if we estimate this, then this is the P hat. So basically we are calculating the mean. Proportion is nothing but the mean. Basically we are calculating the mean here. And on the basis of this sample, we can conclude that this P hat is 64.5%. That means it is more than 50%. So the neonatal right hand side preference is there, exist in the future also. Now, someone calculating 3 pictures, only 3, and according to him, the sample is right, and left. And what is the P hat? P hat is now 2 by 3, that is 66.37%. Even better result. Even in previous case, it is 64.5. In this case, it is 67.7. But the question is, which one you accept, or which result is globally accepted? What is the basis of acceptance? Is there any basis for acceptance this result? Do you accept this result? Any one of you?
So the
Which-
sample size is rather small.
Sample size is small. Any other? All of you got my point? All of you got my point?
So could you please repeat again?
Which part, follow me?
The last part, when we got the result about the left one, then
In the first case, it is 64.5%. 64.5%. In the second case, if we collect only 3 observations, and out of 3, 2 is right, 1 is left, then the proportion is 66.7%. So even with better result. Why? Because previously it is 64.5. Now it is 66.7. So both the studies conclude that neonatal right side preference have some impact on future age. But my question is, both the studies is accepted globally. Do you accept this result?
no, sir, because the sample size is small here.
Because the sample size is small here. 1, 2. Or any other? Any other answer? Please be participate. Don't unmute yourself. Say something. Are you sleeping or listening?
Sir, if we take another sample of some different sample size, then the result may be different.
So all of you considering the sample size, right?
Yes, sir.
Any other? Any other? Bhaskar, don't write in chat. Actually, when I use the PPT or the OneNote, I cannot see in the chat. Please unmute and tell.
Okay, sir.
Please make it is a class.
Okay, sir.
In your class, what will you do? If you don't understand, you ask.
Yes, sir. Yes.
And please participate in the discussion. Actually, consider me as a teacher. That's why the problem. First day I told you, don't consider me as a teacher. You consider me as a friend. Otherwise, it is very tough to teach you in this online mode. Don't hesitate. Please say something. Only 3 have
Sir, can
some
you show
answer.
the PPT once more?
Yes, absolutely. My question is, here the P hat is 64.5%. Here it is 66.7%. Now the question is, which one is accepted result? Both the results you accept, or this one is accepted, or this one. If not accepted, why not accepted?
Sir, can you show the previous slide once again?
Yes. Here it is in 124 and 80 is the number whose picture is right headed. So P hat is this.
And sir, in the next slide, you are writing n equals to 3. What's that for?
N equal to 3. And the result is this. Next
What
slide,
is
n
that
equal to
for?
3. You all, I know you all
Oh, acha.
go through this line. We need a large enough sample size. How large? It is the one point. But the another point is, we need a mathematical modeling to understand the accuracy of this procedure. In this case, this case or the second case, we are not doing any mathematical procedure. Why not? Because in statistics, what is the goal? Remember one thing. What is the goal? Goal is to find out the distribution of our data. Which distribution of our sample data follows? Which distribution of our sample data follows? Suppose we collect some observation from a population. Is the sample data following a normal distribution? It may follow binomial distribution. It may follow Poisson distribution. It may follow hypergeometric. It may follow gamma, beta, whatever will be the distribution. So the first task is to find out the distribution of the sample observations. So if we find out the distribution, then we can say, see, my data following this distribution, and with this distribution, this is the mean value or this is the proportion, and that result is globally accepted result. As long as we are not talking about any distribution of our data is not a globally accepted data. Suppose we are collecting sample for population. So when we collect sample from the population, we assume that our population is following normal. We assume that. If you recall the sampling procedure, simple random sampling, you all know this. It was covered in your syllabus. So what is the basis of the simple random sampling? So observation are coming from a normal population. So you have to justify that your sample also following a normal distribution, probability distribution. That means your sample is following a particular certain population which follows normal distribution. But in this example, we are not considering the population distribution. We are not considering the sample distribution also. We don't know the population distribution. We don't know the sampling distribution for this case. So when we do our research, when we analyze our data, we have to consider first the population and second the sample. And what is our objective? Our objective is to estimate the sample population with the help of the population parameter with the help of the sample statistics. So that's why we need a mathematical modeling to understand which particular distribution our data follows. So this is the first and foremost thing when we do your research. So when we collect our sample, the first goal is to try to fit any distribution to your data. If we fit this, then it is okay. We can move forward. Otherwise, we cannot move. And if you make some result without assuming the distribution of your data, that result is not an accepted one. It is clear to all of you up to this?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
What is statistical experiment? Suppose x1, xn with n independent copies of x. Here we write copies means this is the identically distributed, IID, independent and identically distributed. There is a concept of IID concept. You all know this. What is the goal? Goal of statistics is to learn the distribution of x. I already discussed. Suppose if x follows, only consider two values, 0 and 1. It is very easy. It is a Bernoulli distribution, not binomial. It is a Bernoulli distribution with parameter p. Why? Because if we know the distribution, we automatically know the parameter. So when we know the distribution of a particular observation set, then we can easily calculate the minute. So if we know the population parameter, so it is easy to estimate the population parameter with the help of sample. So first, we know if x follows 0, 1, so it's following a Bernoulli distribution. So what is the parameter for the Bernoulli distribution? It is p. So we can estimate the population parameter from the sample. Now suppose consider this example. What is the example? Here we consider the partial data set. So someone in your college or in university asked to say the number of siblings, including self, and the number collected by some students. So someone say 2, 3, 4, 5, some 1. Some also include the Facebook friends as siblings. So what there are numerous number appears. Numerous numbers appears. Some observation is given here 2, 3, 2, and etc. So what is the distribution of this observation set? How we find? How do you find the distribution set? Distribution of this particular data?
So we find the frequencies of each observation and then plot it against and then find the probability of each of the observations.
Very good, thank you. But this is not the valid solution. According to you, what is your opinion? We just write this probability mass function. Suppose 1 with probability p1, 2 with probability p2, 3 with probability p3. Suppose 4 with probability p4, 5 with probability p5, greater than equal to 6 with p6. One can go move forward. So with the help of this data, you can make this type of probability mass function, PMF. But when you make this PMF, what are the parameters? The parameters are, these are the parameters. So here we consider 6 parameters. So from your sample, you have to estimate these 6 parameters. If we not restrict here, if we move forward, then the number of parameters also increases. Number of parameters also increases. So how you solve? In that case, what we do? We assume. What do we assume? Our distribution, assuming this distribution, whatever may be the distribution. Whatever the distribution, it may be Bernoulli with P, it may be binomial with MP, it may be Poisson with lambda. Up to which part is audible or visible to you?
So you last told that we must form either of Poisson or binomial distribution.
Either a Poisson and binomial distribution. See.
Yes.
So when we considering this, so we can consider either binomial or Poisson or normal. But in reality, when you do a research, we basically consider the normal distribution. Why? Because for binomial distribution, if you limit this, you can get Poisson distribution. From Poisson, it is binomial distribution. And there is a law of large number. Those for statistics past student, you all know. This is a law of large number is there for n greater than 30. All distribution ultimately converges with normal distribution. So we assume our data, that is our sample observation, following the normal distribution. If it follows the normal distribution, then the statistics we use is termed as parametric statistics. When our sample data does not follows the normal distribution, if normality is not there, then we use the statistics which is known as non-parametric statistics. So when we use non-parametric statistics, we use non-parametric statistics when our sample observation does not follow the normal distribution. So in reality, what happened? We collect some sample, but we don't know the population distribution. Suppose someone is working with farmers, they collect some data on productivity, their income, but we don't know the population. But we assume this is the population is following a normal distribution. And if the population is normal distribution, then sample must be a normal distribution. So we have to prove first the collected data following a normal distribution or not. If it follows the normal distribution, then we go for the parametric test. And if the data does not follow the normal distribution, then it is non-parametric test. And another way is, if the sample size is large enough, so even though parametric test is or normality test is not valid there, we can infer that since law of large number is there, so our data automatically following the normal distribution, and we can go for parametric test. So you just remember, when we use parametric test, when our data following the normal distribution or our data have normality. If our data doesn't have normality, does not follow normal distribution, then we have to use a non-parametric test. This is the formal definition. I am not going on details this. Let's consider another case study, another example. All of you heard about Kolkata Marathon?
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
So this is a data set available on Washington Marathon. I just convert this for Kolkata Marathon. For Kolkata Marathon, no such data set is available. But in Washington Marathon, their entire data is available. I just convert this in Kolkata Marathon case study. So what is actually available data with us? In 2007, there are 4974 participants, and the average running time is 103.5 minutes. These are the past data available. 2017, 4974 participants are there, and the average running time was 103.5 minutes. So average running time means average of all participants. Next, the question is, were the runners faster in 2018? How we solve this problem? We have available information. In 2017, there are 4974 participants. Average running time is 103.5. Next, the question is, In 2018, is the average running time is higher than this? Or the faster than this? How we answer? What is the first task? What is the first task for this?
So we have to form a sample of 2018 participants.
We have to
Form a sample of 2018
form a
data.
sample, not form a sample, we have to collect sample. Or we have to collect the total population. Since data is available, one can use all population of the total all participants, or one can collect some sample.
Yes.
Two scenarios is there. Since in 2017, this is the entire population, 497 crores. So similarly, in 2018, data for entire population is available. So one can collect the data of entire population, or one can collect the sample. Now, from this data, 4974 observation, it is calculated that this is the mean value and this is the variance, and luckily this following a normal distribution. That means in 2017, the data of the 4974 participants is following normal distribution with mean 103.5 and variance 373. So here we know the population parameters. These all are the population parameters. These are the populations. 103.5 mean, it is the mu. 373 is the variance or sigma square, and it follows the normal distribution. That means our population is following normal distribution. So when we collect sample, that means that sample must be following a Poisson distribution. But the question is here, this population is for 2017, but we are considering the population for 2018. Now, what is our actual question? Were the runners faster than 2018? Or basically, if the average running time is more than this or not. So, what are the hypotheses we can set? We can set either this mean value in 2018 is not equal to this, or the variance value is not equal to this, or x1 may not be a Gaussian distribution. That means in 2018 the observation does not follow the normal distribution, it follows another distribution. So you can set any one of these hypotheses. Suppose we consider the simple one, this one. Expectation of x1, that is mu, is less than 103.5 in 2018. We can consider any one of these hypotheses. So different hypothesis is there. You can use any one. How we fit the right hypothesis, how we choose the right hypothesis on the basis of the domain knowledge, on the basis of the research object. So what is hypothesis? Hypothesis is nothing but a objective method of making decision or inferences from a sample data. So from sample data, when we try to estimate the population, we make some hypothesis. And there are two hypotheses. One is null hypothesis, one is alternative hypothesis. And basically null hypothesis is basically the population hypothesis. And the alternative hypothesis is termed as research hypothesis. And remember one thing, when we write our hypothesis is always in terms of the population parameter, not in terms of the sample statistics. We always write our hypothesis in terms of the population parameter. And in case of null hypothesis, what do we write? Null hypothesis basically is, we assume it is begin with, typically there is no difference, no effect, no relationships, mean is 0, variance is 0, or equality of mean is there. This is the basically the null hypothesis. And what is the alternative hypothesis? There is difference, there is some effect, there is some relationship. So this is the research hypothesis. So what we willing to do in hypothesis, we form our hypothesis on the basis of the population parameter. I will show you in different cases. See, in our previous case, see, if we form the null hypothesis, this on the basis of the population parameter, 1035 is the population parameter. This is the if the null hypothesis is this based on the population parameter. So, what is the alternative hypothesis? Alternative hypothesis is the research hypothesis. When we making, there is no difference, there is no effect, there is no relationship. So first we set our hypothesis. So what are the procedure? Procedure is first we check our sample data, collect sample data. On the basis of the sample, we first check our sample data following normal or not. If it follows normal, then it is okay. We go from the non-parametric test. If it does not follow the normal, go for the non-parametric test. Next, we frame our hypothesis. There is a null hypothesis and alternative hypothesis. And remember, hypothesis always based on population parameters. And now the questions come of testing. How we test this hypothesis? How we test this hypothesis is, in our example, is mu is equal to 103.5 or not. So this is the null hypothesis. Mu is 103.5 or not. So how we test? What is the exact statistical test we can use to test this null hypothesis against this alternative hypothesis? What are the exact tests? So the next few steps are, first is we have to set a suitable level of significance. So now, what is the meaning of level of significance? In practice, we use 5% level of significance, etc., etc. So what is the meaning of level of significance? Can anyone of you from statistics pass? You can say what is level of significance? What is the meaning of level of significance? All of you know what is level of significance?
Sir, that is basically the area of the rejection zone, or it can be otherwise stated that level of significance, say 5%, so that much amount of error I am accounting in my prediction.
What is error? And
Uh,
what is prediction? Are you predict something?
Yes, sir, we are making a conclusion whether the null hypothesis will be accepted or the alternate will be accepted.
Is it prediction?
Yes, sir. I mean, like we are claiming something.
Not you are claiming something. And if you assume or if you claim something, so your claim is not prediction. Prediction is totally different thing. In hypothesis, when you test something, you are not predict something. Rather, you claim something. You try to validate your statement. So what is error?
Sir, if I consider the significance level to be 5%, so that means if my that statistic value falls beyond that 5%, that much I am accepting as error in my conclusion. Or
So what is error? That is my question.
স্যার
Yes.
স্যার এরর মানে মানে অনেক সময় আমাদের স্যাম্পল নিতে তো ভুল হয়, এবার সেইটা কতটা আমার ভুল হয়েছে সেটা মেজার করতে আমাদের এরর টার্মটা আসে।
But you are
এবার
talking about
লেভেলে
sampling error. You are
হ্যাঁ
talking about
হ্যাঁ
sampling error.
হ্যাঁ স্যার।
Any other? You can free to speak in Bengali. No problem. Don't hesitate. Any other? Do you heard the term type 1 error and type 2 error?
ইয়েস স্যার।
Yes, sir.
Can you remember which one is type 1 error and which one is type 2 error?
yes, sir.
Can you say which one is type 1 error and which
Sir,
one is type 2
type
error?
1 error is when we reject the null hypothesis like that. I don't remember exactly, but
No,
we re
that is the most crucial and vital thing in statistics.
So
And
type 1 error happens when we mistakenly rejects the null hypothesis even though it is correct, and type 2 error happens when we mistakenly accept the null hypothesis even though it is wrong.
yeah, and this is the most vital thing in statistics: type 1 error and type 2 error. So in this class, if I speak a story in Bengali, is it any problem?
no,
For
sir.
5 minutes?
No, sir.
No, sir.
All of you.
No problems.
So can I tell a story in Bengali?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
ধর একটা পাড়ায় একটা পুজো হয়েছে, সেই পুজো পরে খিচুড়ি আর আলুর দম হবে। তো খিচুড়ি আর আলুর দম যখন হবে, এবার দায়িত্ব পড়েছে একজনের কাঁধে আলু কিনতে যেতে হবে। সে গেছে বাজারে, সম্রাটই গেছে বাজারে। সম্রাট বাজারে গিয়ে আলু কিনছে। আলু যখন কিনতে যাচ্ছিস তোরা, তখন কি করছিস? একটা অনুষ্ঠানের আলু মানে পাড়া শুদ্ধ লোক আলুর দম খাবে মানে তো 3-4 বস্তা আলু লাগবে। তো গিয়ে একটা দোকানে দাঁড়ালি, দাঁড়িয়ে বললি, দাদা আপনার আলুর দাম কত এবং আলু কেমন হবে? আর বলে দিয়েছে পচা আলু আনবি না, বেশি দাগি আলু আনা যাবে না, বাদ দেওয়া যাবে না, মোটামুটি আলু আনতে হবে পয়সা দিয়ে। তো প্রথমে কি করলো, যে দোকানটায় গেল সেই দোকানে গিয়ে বললো, কিরম আপনার দোকানে কি আলু আছে দেখান। সে দোকানদার তাকে আলু বের করে দেখালো। দেখার পরে সে আলুটা যখন সে নিল, তার মানে কি আলুর যে বস্তাটা, সেই বস্তাটা হচ্ছে পপুলেশন, এবং আলুটা যখন সে কালেক্ট করছে, দ্যাট ইজ দ্য স্যাম্পল। তাহলে 5টা বা 6টা বা 7টা আলু নিল, এবং এই 6টা বা 7টা আলু নেওয়ার পর সে দেখলো যে 6টা 7টার মধ্যে 3-4টি খারাপ, দাগ রয়েছে, পচে গেছে আলু, বর্ষাকাল, আলু পচে গেছে। তো তখন দোকানদারকে জিজ্ঞেস করলো, আপনার তো আলু সবই দেখছি পচা, আপনার বস্তা কি এরকমই আলু হবে? তো দোকানদার বললেন যে এখন বর্ষাকাল, এই সময় এরকমই আলু, এর থেকে ভালো আলু এখন পাবেন না বাজারে। তো সে দেখলো এত পচা আলু নিয়ে গেলে তো লোকজন গালাগালি দেবে পাড়ায়, সে তার থেকে আলুটা নিল না। আমি ঘুরতে ঘুরতে আবার একটা দোকানে গেল, সেখানে গিয়ে সে জিজ্ঞেস করলো যে আপনার আলুর দাম কত? দেখলো একই দাম আছে। একই উপায়ে সে ওই বস্তা থেকে কয়েকটা আলু নিল। তারপর আলু দেখুন, এই তো বস্তা খুলে দিচ্ছে, আলু দেখুন, আলু সব ভালো হবে। সে আলু নিল, 6-7টা আলু নিল, দেখলো 6-7টা আলুই ভালো। দেখলো এর দোকানের তাহলে আলু ভালো আছে, তো ওর থেকে 2 বস্তা আলু নিয়ে চলে এলো। আসার পরে যখন আলুর বস্তাটা খোলা হলো, তখন দেখা গেল কি, যে ওই আলুর বস্তার ওপরের দিকের আলু বাদ দিয়ে ভেতরের ম্যাক্সিমাম আলুটাই খারাপ। এবং আলটিমেট কি করলো, দোকানদার তাকে ঠকালো। প্রথম ক্ষেত্রে কি হলো, প্রথম ক্ষেত্রে দোকানদার সত্যি কথা বলেছিল, কিন্তু সেটাকে সে অ্যাকসেপ্ট করেনি। দ্বিতীয় ক্ষেত্রে কি হলো, দোকানদার মিথ্যা কথা বলেছিল, সেটাকে সে অ্যাকসেপ্ট করে নিল। প্রথম যে ক্ষেত্রটা হলো, যখন সত্যি কথা বলছে তাকে অ্যাকসেপ্ট করছে না, দ্যাট ইজ ট্রু হাইপোথিসিসকে আমরা অ্যাকসেপ্ট করছি না, দ্যাট ইজ টাইপ 1 এরর। যখন আমরা ফলস হাইপোথিসিসকে অ্যাকসেপ্ট করে নিচ্ছি, তখন সেটাকে বলছি আমরা টাইপ 2 এরর। তাহলে টাইপ 1 এরর কাকে বলছি? when we don't accept true hypothesis, it is type 1 error. হাইপোথিসিসটা ট্রু, বাট সেটাকে আমরা অ্যাকসেপ্ট করছি না, দ্যাট ইজ টাইপ 1 এরর। টাইপ 2 এরর কাকে বলছি? যখন আমি ফলস হাইপোথিসিসকে অ্যাকসেপ্ট করছি, দ্যাট ইজ দ্য টাইপ 2 এরর। ইট ইজ ক্লিয়ার টু অল অফ ইউ?
Yes, sir.
Yes, sir.
Yes, sir.
গল্পটা মনে থাকবে?
হ্যাঁ স্যার।
হ্যাঁ।
স্যার বলছিলাম যে আমরা তো অ্যাকসেপ্ট এমনিতে বলি না, আমরা তো রিজেক্ট আর নট রিজেক্ট বলি।
একদমই তাই, ডু নট রিজেক্ট, রিজেক্ট।
হ্যাঁ, সেটাই।
স্ট্যাটিস্টিক্যালি আমরা তাই বলি, রিজেক্ট, ডু নট রিজেক্ট।
রিজেক্ট।
একদমই আমরা অ্যাকসেপ্ট বলি না, কিন্তু পড়াতে গিয়ে অ্যাকসেপ্টটা না বললে বুঝতে অসুবিধা হবে। গল্পটা তো মনে থাকবে না, মনে থাকবে না, ভুলে যাবি?
না না, মনে থাকবে।
থাকবে স্যার।
মনে থাকবে স্যার। মনে থাকবে
If you-
স্যার।
If you remember this story, I think always you remember what is the definition of type 1 error and type 2 error. So I will give you this PPT and the story is written here. So what is happening here? One is type 1 error and one is type 2 error. And both are error. So if we try to minimize one error, automatically another error increases. If we try to decrease the type 1 error, automatically type 2 error increases. Or if we try to decrease the type 2 error, type 1 error increases. So we cannot decrease both the errors at a time. So what we do here, we fix one error and try to minimize the other error. We fixed one error. Which one error? Probability of type 1 error. And we fix this as suppose 5%. So what it means? It means out of 100 case, only 5 cases there when we do not accept the true hypothesis. When it is true. Otherwise, in 95% case, we accept the true hypothesis. So that is called as confidence interval. That is the 95% confidence interval. So when we talking about the 5% level of significance, what it means? It means out of 100 case, only 5 cases is there where we do not accept the true hypothesis or the null hypothesis which is true. And that means in 95% case, we are accepting the true null hypothesis or the true hypothesis. So this is called the confidence interval. So the 1 minus level of significance is confidence interval. Basically in statistics, in notation, it is denoted as alpha. Alpha is the level of significance and 1 minus alpha is the level of confidence. And in practice, we use 5%. One can use 1%, one can use 10%. But nowadays, in the era of statistics, we use the concept of p-value, not the level of significance. We consider the value of p-value. I will discuss the p-value when we go going on R. So nowadays, we basically discuss the concept of p-value. I will discuss this. So now consider this case. So example 1. A coin is tossed 80 times and heads are obtained 54 times. The question is, can you conclude that the coin is significantly unfair? What do you do here? Simple. Try to find out the x bar or the probability. 54 by 80, this is 0.68. What is the null hypothesis? Null is p is 0.5. If it is not biased, if it is biased, then it may be less than this or more than this. And using central limit theorem, what is central limit theorem? Central limit theorem tells us for large number, when n greater than 30, this is the sample mean, this is the population mean, and this is the population variance. That means central limit theorem tells us, CLT tells us, for large number, it's following normal 0, 1, standard normal. It's following normal 0, 1 using central limit theorem. X bar minus mu by sigma by root n is following n01. So when you're talking about this Bernoulli distribution, we can calculate this just like our first example. It is not enough to conclude statistically. So for conclude statistically, what we do, we make using central limit theorem. We make is the standard normal variable, and if we calculate the value, the standard normal value is 3.22. This is the Z value, and we know from Z table is available, and 5% level, it is the value is 1.96. We all know this. But what is there any table available for Bernoulli distribution, for binomial distribution, for Poisson distribution? No table is available. So that's why we make these as a standard normal variable or Z. So the value is 3.22. Clear? So, and 5% level, the value is 1.96. So we can easily make our conclusion on the basis of the table value of Z at 5% level. See, next example. The same example. Here the number change and the p-value changes. The Z value is minus 0.77. Clear? So Z is here 0.77. It is less than 1.96. It is less than 1.96. If we consider this, this is normal curve. Suppose this is 1.96. This is 3.22. We are taking absolute value 0.77. So as we know, this is the confidence interval, and this is the rejection region. This is the rejection region. This is the confidence region. This part is the confidence region. So this is our pen paper concept. Calculate the Z value, see the table value, then conclude. And this is the conclusion on the basis of the value of 1.96 at 5% level. Clear? Up to this clear?
Yes.
sir.
Yes, sir.
Yes, sir.
Now the question is, for what level of alpha would psi alpha not reject 80? Suppose we are not considering this 5%. We try to calculate some value of psi alpha for which this 80 is not rejected. And in that case, the concept comes the p-value. What is p-value? P-value is the test of psi alpha is the smallest or the asymptotic level of alpha at which psi alpha reject 80. This is the smallest possible value of alpha for which we reject 80. The smallest possible value for which we reject the 80. This is the null hypothesis. And what is the rule of thumb? The rule of thumb we use, if p-value is less than 0.05, reject null. This is the rule of thumb. In statistics, we use the rule of thumb like this. If p-value is less than 0.05, then we reject null. And alternative is, if p-value is more than 0.05, we do not reject null. Clear?
Yes, sir.
So the first one case, the p-value is 0.01. It is less than 0.05. So we reject null. Here, this is 0.44. That means it is more than 0.05. So we do not reject null. So in first case, we reject the null hypothesis. In second case, we do not reject the null hypothesis. Why? Because in first case, p-value is 0.01, which is less than 0.05. So we reject null. In second case, it is 0.44, which is more than 0.05. Implication: do not reject null. Do not reject null.
Sir, I have a question.
Yes.
So, sir, that means p-value, the standard value of p is 0.05. So that means the standard significance level is 5%. I mean, we should consider
How you use the, why you use the term standard? There is no concept of standard.
like, sir, you mentioned rule of thumb. So
This is a rule of thumb. If p-value is 0.05, this is not the standardized value. When you call the standard in statistics, it means standardized value. Be cautious. When you use the term standard, that means standardized p. So be cautious. I am talking to, this is a rule of thumb. If p-value is less than 0.05. So that means the level of significance is 5%.
It's 5%. We
If it
fix
is
this
less
for
than
all
equal
our
to
calculations.
0.05, reject null. If it is more than 0.05, do not reject null.
Yes.
This is the rule of thumb.
Yes.
You do any kind of statistical test, but the rule of thumb is this. You look p-value. If it is less than 0.05, reject null. If it is more than 0.05, do not reject null. This is the rule of thumb. Clear up to this?
Yes.
Now the question is how we measure normality, how we check normality. You can check normality using by histogram or QQ plots. You already know how to draw histogram. I will show you how to draw QQ plot. So if the histogram is more or less symmetric like this is the figure. So then you can infer your data follows normality. Or in QQ plot, this is a quantile plot. It actually plot the estimated quantiles with the theoretical quantiles. If this line is the theoretical line and this point is the estimated line points. If all the points are on the line or near to the line, we can infer that our data following normality. And you can check by some statistical test. It is Shapley-Wilks test or Komlogov syndrome test, by which you can also check that your data follows normality. What is the null hypothesis under this test? Under both the tests, the null hypothesis is the sample data are not significantly different than the normal population. Remember one thing. What is the null? The null is the sample data are not significantly different than a normal population. What is the alternative? The sample data are significantly different than a normal population. So when we test our data is following normality or not, then what is the rule of thumb? In case of normality, when you check the normality, what is the rule of thumb? If p-value is more than 0.05, implies data follows normal. If p-value is more than 0.05, that means we do not reject null. What is the null hypothesis? This is the null hypothesis. The sample data are not significantly different than a normal population. So that means to check normality, what is our objective? We do not reject the null. If we reject the null, that means our data is not following normal. That's why for normality test, the rule of thumb is slightly different than the other statistical test. Don't confuse with this. I earlier told you the rule of thumb is this. This is the rule of thumb. Here also the rule of thumb is same. P-value is more than 0.05. That means we do not reject null. So do not reject null mean the sample data are not significantly different than a normal population. The sample data are not significantly different than a normal population. So if for normality test, if the p-value is more than 0.05, then there is a huge relief. Why? Because our data following normality. We can go for parametric test. So up to this clear?
Yes, sir.
Yes, sir.
Yes, sir.
Am I able to clear your concepts?
Yes, sir.
Yes, sir.
Yes, sir.
Next, our objective is testing. This is the population, X following normal. We are collecting sample. From this population. We are collecting samples from this population. We know population following normal mu sigma square. Case 1. When we try to test the mean value, that is our null hypothesis is mu equal to suppose mu 0 against the alternative mu not equal to mu 0, and sigma square is known. We know the sigma square. We know the sigma square, and we try to test the mean. So what we try to test? The population mean. What is our assumption? Population following normal mu sigma square. Sigma square is known to us, and we try to test this. What is the statistics we can use for that purpose? What is the relevant statistics? When we test this, case 1, sigma square is known. We try to test the mean of the population, and our null hypothesis is mu equal to mu 0 against the alternative mu equal to not equal to mu 0. One can write the null hypothesis like this: mu is greater than mu 0. One can write mu is less than mu 0. So when we're talking about this is we call as two-tailed test. When we write this type of hypothesis, we are considering the one-tailed test. This is the example of two-tailed test. Here the example is one-tailed test. We consider this example. In 1990, 30 to 39-year-olds men in Kolkata had a mean mu body weight 65 kg, standard deviation 4 kg. So population mean is known, population standard deviation is known. We test whether mean body weight in the population now differs. Now it is differs or not. So what is the null hypothesis? Mu equal to 65, no difference. Mu not equal to 65, alternative hypothesis, that is difference is there. And we collect a sample of size 50, and what is sample mean? Sample mean is 63. How we justify the null hypothesis? We reject the null hypothesis, or we do not reject the null hypothesis. We have to form a statistics. Which statistics?
Z statistic.
Which statistics?
Z.
Z statistics. Fine, very good. So we have to calculate the Z statistics. What is Z? X bar minus mu by sigma by root n. Or we can write this root n into x bar minus mu by sigma. If we put the values of this, root 50, x bar I think 63, minus 65 by 4. If we calculate this, we can calculate the value of Z, and we know the 5% level, the total value is 1.96. If it is greater than this, then we reject null hypothesis. If it is less than this, we do not reject null hypothesis. The simple one. You do lots of problems on this particular Z statistics. In the books of N.G. Das, in the books of Gungupta, Dasgupta, lots of problems is there. Clear? Now, we move to case 2. Here also we try to test null hypothesis. Not equal to mu 0. But now sigma square is not known. Sigma square is not known. So we cannot use the Z statistics because sigma square is not known. So how we test this? So when sigma square is not known, we have to estimate this sigma square from sample, and the unbiased estimator of the population variance is S prime square, that is 1 by n minus 1 x bar square. And in that case, we use the formula x by root n, which follows t with degrees of freedom n minus 1 and level of significance suppose alpha n minus 1. So this is the expression, and this expression follows t distribution. That's why the statistics is known as t statistics. Why it is t? Because it follows the distribution t. It does not follow the normal distribution. It follows the t distribution, but it's coming from the normal. It's coming from the normal distribution, and we use the t statistics. So when sigma square is not known, we have to estimate the sigma square from the sample variance. In that case, we use the statistics which is known as t. And the expression of t is x bar minus mu by s by root n. Just see this slide. These are the observations. Population is this. I am using different notation here. These are unknown. Theta and sigma square is unknown. This is the null hypothesis. So this is the relevant statistics. This follows t distribution with n minus 1 degrees of freedom. So statistics t is this, and forget about these lines because we are, if you're using the softwares, we are only considering the p value. So statistics in software returns you the t value along with the p value. So what is the rule? If p value is less than 0.05, we reject null. If p value is more than 0.05, we do not reject null. This is the case when there is only one sample. When there are more than one sample. When there are more than one sample, that is two independent samples. Or basically two samples, not independent, two samples. Sample may be independent or paired. What is the difference between independent and paired? When we do some experiment on the samples, on two samples which is independent to each other, male, female, different sample. Persons with less than 40 years age, persons with more than 40 years age. This is the independent sample. So when it paired sample means when we do our experiment on same sample. It is the pre-post concept. So suppose if any examination taken before the workshop and another examination taken after the workshop, that is the concept of paired sample. So when you're talking about the two sample case, then there are two samples are there. One is paired data, that is individuals studied at two different times under two or different conditions, but the individuals are same. And next is the independent sample where data collected from two separate groups. So for independent sample, it is independent sample t-test. For paired sample, we have to use the paired t-test. What are the assumptions? Assumption is normality and equal population variance. You have to test this. So if normality is not there, you cannot run the independent sample t-test or paired sample t-test. Similarly, if normality is not there, then you have to go for non-parametric test. Another assumption is equal population variance. If we assume population variance is equal and we test this, and for this purpose, the test is Leven's test. Leven's test is there. And if we test this and do not reject the null, that means population variance is equal, then we can use the statistics named as students t. And if the variances are not equal, then we can use the statistics which is known as Welch t. So when we use student t, we use student t when population variances are equal for two groups. When we use Welch t, when population variance are not equal. So first we have to check the normality by using Sharpey-Owill or Komolov test. Then we have to check the equal population variance by Leven's test. and then we go for this test. If the population variance is equal after testing, go for students T, otherwise go for Wells test. Theoretical part is clear?
Sir, one question from here.
Please.
So, sir, a student's t-test can be used, or in general, t-test can be used to compare the means of two different populations,
Yeah.
provided the variances are same.
Yeah.
Okay, okay. No, actually, we were told that when there are two different populations or two different samples, then application of t-test fails, and then f-test comes into picture. So,
No.
that's
Remember. You confused. Here population is two. Two population case, population variance is not equal.
yes.
See this. Sigma 1 equal to sigma 2, your null hypothesis. Alternative is sigma 1 not equal to sigma 2. So if you do not reject this, sigma 1 equal to sigma 2 after Leven's test of homogeneity. Leven's test of homogeneity. If we do not reject this, then go for students T. Right? Otherwise, Welch. Otherwise, Welch. So you have to first check this. You have to test with the help of Leven's test. If sigma 1 equal to sigma 2, then you can use students T. Otherwise, you can use Welch test. That means when variances are not equal.
Okay.
Clear?
Yes.
Up to this, it is clear?
Yes, sir.
Yes, sir.
Just a minute. Now, when there is more than two population, that is mu1 equal to mu2 equal to mu3 equal to suppose mu(n). This is your null hypothesis. How to test this null hypothesis? And variance is not known to you. In that case, we use a concept is termed as one-way ANOVA. Comparison of three populations. Comparison of three populations. So what is the meaning of one-way ANOVA? Can anyone tell anything about ANOVA? What is the meaning of one-way ANOVA? Are you feeling bored? Or is it okay to all of you?
Yes, sir, it's fine.
Actually, you are waiting for our code, but I am discussing the statistics. Is it okay to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Because the thing is, if you don't know the statistics, you cannot write a word, single line of code. So, what is the concept of one-way ANOVA? Please take the concept.
Sir, basically it compares the sample mean, means two sample means and try to find out whether they are very significantly different or not.
Remember one thing: we use ANOVA when there is more than two population. How you get the two sample?
So by the ANOVA, we test by the F test, and we calculate the RSS, ESS, and TSS there.
This is the mechanical part. You all know the mechanically. But my question is, can anyone tell me why it is we are testing mean? Basically, we are testing mean, but why it is analysis of variance?
So because we are taking two different samples, that's why.
We are taking more than two type sample. Please remember, we use ANOVA where there is more than two populations. You can use for two population also, but generally we use ANOVA for more than two populations. But what is the full form of ANOVA? Analysis of variance. So we are testing mean and talking about analysis of variance. Why are we talking about analysis of variance? My question is very simple. You are a student of economics, you are a student of statistics pass. So someone asks you, you know ANOVA? Yes, sir, ANOVA. What is the full form of ANOVA? ANOVA, analysis of variance. So what it means? You are testing mean, but the possibility is analysis of variance. Why variance comes here? To test the mean? Can all of you understand? Understood my point?
Yes, sir.
Just take the concept. Take the concept first. Suppose this is population 1. And what are the population? Values are y11, y12, similarly y1, n1. Suppose this is population 2. y21, y22 and y2n2. Similarly, more than two populations, suppose population G, G1, YG2 and YG, NG. These are all the observations. What is our null hypothesis? What is our null hypothesis? Our null hypothesis is mu1 equal to mu2 equal to mu g. This is our null hypothesis. Suppose we write this mu1 equal to mu plus mu1 minus mu. Any problem? We can write this mu1 equal to mu plus mu1 plus mu l, or we can write here mu l equal to mu plus mu l minus mu, or we can write this mu plus tau l mu plus tau L. What is this mu L? What is this mu L?
Mean of the population mean of the LH population.
Mu L equal to mu plus tau L. This is the Lth
Population mean.
population mean. What is mu? What is mu? It's a grand mean. Or you know the formula x bar equal to n1 x1 bar plus n2 x2 bar plus n3 x3 bar.
Yes.
This is the formula. And what is tau L? What is tau L? Tau L is Lth population effect. Alternatively, we can form the null hypothesis H naught equal to tau 1 equal to tau 2 equal to tau g equal to 0. Just a minute. So if we write this alternatively, can I unmute us? Am I audible?
Yes,
Yes.
sir.
Yes, sir.
Yes, sir.
Yes,
Oh,
sir.
fine. So alternatively, we can write this tau 1 equal to tau 2 equal to tau g equal to 0. Why? Because if tau 1 equal to 0, that means Lth population mean equal to grand mean. So no difference with grand mean and the population mean. There is no difference with Lth population and the overall mean. Both are same. So if we alternatively form this null hypothesis, we can write the another null hypothesis H0 equal to tau 1 equal to tau 2 plus tau z equal to 0. Is there any problem?
No,
No,
sir.
sir.
No, sir.
So we can write for individual item, for individual particular item. Suppose this is one observation. So generalized, we can write this YLJ is equal to mu plus tau L plus epsilon Lj. What is ELJ or epsilon Lj? This is the error. So any individual observation, we can decompose any individual observation like in terms of these three parameter. This is the parameter. So in case of sample sense, we can write this YLJ is equal to Y bar, this is a sample mean, plus Y bar L minus Y bar plus YLJ minus YL bar. So this replaced by this tau L replaced by this, and error is replaced by this. So Y bar is the overall sample mean. This is the estimated effect. This is the tau L, and this is the residual. So if we go back to the PPT, what we write here? This is the sample. Population 1 969. This is 02. This is 312. So what is the grand mean? What is the grand mean? If we add all this, 9 plus 6 plus 9 plus 0 plus 2 plus 3 plus 1 2 by 8, you get 4. Clear? So this is the grand mean. Next is YL bar minus Y bar. It is individual group mean. 9 plus 6 15 plus 9 24 by 3 8. Clear? So 8 minus 4, what is 4? In this case, x1 bar equal to 8. y1 bar is 8. So y1 bar minus y, this is 4, 4, 4. Similarly, in this case, this is 1, 2 by 2. So 1 minus 4, this is minus 3. This is minus 3. So this is 4 plus 4, 8. The residual is 1. Similarly, the residual is here minus 2. 6 minus 8. 9 minus 8, it is 1. The last one is, the last part is this. Say for example, if you consider suppose you consider this value 3. This is the x31 value. Sorry, y31 value. This value. So what do you write here? y31. What is y31? y31 is y bar plus y31 minus y3 bar. So what is y bar? Y bar is 4. What is y3 bar? Y3 bar is 3 plus 1 plus 2 by 3, that is 2, minus y bar, that is equal to 4, plus the value is 3 minus 2, and this is equal to 3. So you can decompose every element with respect to these three terms: y bar, this plus this, y bar, this plus this. So this is the grand mean, this is the treatment effect, this is the residual. Now in generalized case, if we deduct y bar from both sides, so what do we get? Minus y bar is equal to this, and then we take square both sides, deduct y bar and then square, and then square. What do we get? This square, this square, this square plus 2ab term, plus 2ab term. Any doubt up to this part?
No, sir.
No, sir.
No, sir.
No, sir.
And if we sum all over n, this cross product is equal to 0. This cross product is automatically equal to 0. So the remaining terms is this one, and this one. Why this 0? Because if we sum this, then automatically 0. Sum over xi minus x bar equal to 0. You all know this. Deviation about mean is equal to 0. And if we sum this, it automatically becomes 0. So remaining part is this. So what we can write here? We can write here, if we sum this, sum over y li minus y bar square is equal to, after summing, y bar square plus sum over y l j minus y l bars whole square. And what is this? This is the value minus grand mean. Value minus grand mean. This is termed as sum square total. What is this? This is termed as sum square between, and this is sum square residuals. This is the between effect. YL minus Y bar. So in between, what is the grand mean and the group mean? And this is the individual error effect, individual observation to the mean of that particular group. So this is sum square total, this is sum square between, and this is sum square residual. And if we divide this sum square between by degrees of freedom, sum square residual by degrees of freedom, we get mean sum square between mean sum square residual, and the ratio of MSB and MSR. This actually follows the F distribution with degrees of freedom N1 and N2. So why we use ANOVA for F? Because of this decomposition. We try to find out this between effect and the residual effects. And see what is the relation. Actually the relation is, what is F? F is nothing but the between by residual. So if between is more, residual is less, that means F increases. If B is greater than R, then implies F is increases. If between is more, that means sum square between is higher, that means residual is less, so it is better for our result. That's why always in statistics we are willing for high F value. High F value means between effect is higher. Between effect is higher means there is error is less. What is our objective? Minimizing the error. So if the error is minimum, between is high, so F value automatically high, and in F value automatically high, F value automatically is a significant F value, and if low F value is a not a significant F value. So if F value is high, that means between is high, residual is low, so automatically it is better for our analysis. So between effect is higher, residual is lower. So that's why to test the mean for more than two population, we use the concept of this variance. Why we use this concept of variance? Because we decompose like this. Decompose like between effect and this effect. So this is a grand effect, this is a between effect, this is the residual effect. And if we deduct this and square this, we can get the sum square. And the ratio between sum square between and sum square residual by their corresponding degrees of freedom gives us the value of F. That's why in ANOVA we use the F statistics. Why we use F? Because of this fact. Why we use analysis of variance when doing the test of T? Because of this decomposition. We want to find out the between effect. We want to find out the residual effect. And the entire multivariate statistics, whatever you know in future, entire multivariate statistics, say for example factorial analysis, conjoint analysis, multidimensional scaling, you can say for multivariate ANOVA, whatever you can learn, entire is depends on sum square between and sum square within. So this is the main key factor, sum square between. And entire multivariate statistics depends on this sum square between. So what is sum square between? I think it is clear to you. So now this is the sum square. If we add this is the mean value, this is the group value, this is the residual value. If we add this, sum square total is this, sum square mean is this, group is this, residual is 10. So sum square corrected is 88. And in ANOVA table you can find this MS group is SS MS residual, sum square residual by this. So this is the F statistics with the degrees of freedom 2.5 for this example. So up to this it is clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Sir, one question.
Yeah, absolutely.
Sir, so what will be the decision rule for the test? Like higher F value would mean the null hypothesis is rejected, right?
Yeah. Higher F value actually implied that null hypothesis may be rejected. You can reject this on the basis of p value, but it can be say that higher F value basically when F value is higher, p value is less than 0.05.
Okay.
So it is clear to all of you.
Yes, sir.
Yes,
Yes,
sir.
sir.
So today no R. I will show you the R codes of the entire things tomorrow.
Okay, sir.
Okay, sir.
Okay, sir.